Hi, I'm Mr. Hoover, and in this video we're going to look at 3D. Rewrite each function in factored form, find its zeros, y-intercept and vertex, and sketch the graph qualitatively. So f of x is x squared minus 16x minus 36. So now, once you get the knack of it, you could possibly write it down directly. We'll do it step by step here once more. So 36 could be 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And you need a minus 36 here, so you have 1, 2, minus 1 and 36, and 1 minus 36, so you have 2 options here, 2 options here, 2 here, and 2 here. 1 option here because it's 6 times 6, so either the first one is minus or the second one is negative. It doesn't matter, it's 1 option. So you have in fact 9 options to check or at hand. But then you know that when you add them up, it has to be a minus 16. So only one pair gives you that option, and that's the 2 times 18. Look, 2 times minus 18, that's minus 36. And 2 plus minus 18 is minus 16. So this will be it. So you can write plus 2 and minus 18. Now you can work out the zeros. Let's set this equal to 0. So x plus 2 is equal to 0. X is minus 2. X minus 18 is equal to 0. So x is 18. So these are your 2 zeros. And you know your y-intercept, which is at 0 minus 36. So you can more or less sketch a graph here and say, well, this could be your minus 36. This could be your 18 here. This is probably your minus 2. So your graph would probably look somewhat like this. Here we go. A nice and smooth and rounded shape. So now we know that this function is symmetric with respect to this vertical line through the vertex. So minus 2 plus 18 divided by 2, that's 16 divided by 2, that's 8. So the vertex will be at 8. Well, we need to work out the y-intercept. Well, that's quite easy to do. F of, so this is xv, f of 8 is 8 plus 2 times 8 minus 16. So that's in fact minus 18. That's 10 times minus 10. So it's minus 100. So apparently our vertex is down at minus 100. Okay. So clearly it's a very mediocre hand sketch, but it helps to understand what the graph looks like. You could obviously get a better one and say, well, let's say this is minus 36. This would be minus 100. And here like this. And you would try and do something like this. So this would be your 18, this would be your minus 2, this is your minus 36, and this is your minus 100. Okay, it's a bit longer, a bit more elongated. But it doesn't matter, even if you have something like this, it's good enough for us for the moment, because it said just draw a qualitative sketch. Obviously, it's not that nice if it's almost 3 times lower down, and here it's clearly maybe at 1/2. But it still gives us an idea about the graph. Now look, I would like to do this with the old method here, okay? Let's do the same thing again. F of x is x squared minus 16x minus 36. So f of x, let's complete the square, x squared minus 16x plus 8 squared minus 8 squared minus 36. So you get, this is your perfect square, x minus 8 squared minus 64 minus 36. So the vertex form would be x minus 8 squared minus 100. Vertex is at 8, 100. Minus 100, sorry. The y-intercept is obviously still 0, 36. Then you could work out the zeros. As I told you in problem 3a, the additional information, I told you that you can use this method each and every time. Not like this, you have to be a bit lucky that you find two integer solutions that make this possible, and you have to deal with quadratics that have zeros, okay, real zeros. But here, well, all that's left to do is to work out the zeros. So f of x is equal to 0. It's particularly interesting here, or simple. X minus 8 squared is 100. Now you take the square root, so x minus 8 is plus minus the square root of 100. X minus 8 is plus minus 10. X is 8 plus minus 10. And you get, with the plus, you get 18. And with the minus, you get minus 2. So you would have got everything you get here. Well, this is oftentimes a bit faster than this, especially when the numbers are a bit more difficult. Here, in this case, the numbers are very easy, and both methods are equally laborious, okay? But if the numbers are more complicated, then oftentimes this can be a very good solution. Well, in some other cases, this is the better solution, okay? But here, it's more or less the same thing. But the idea is, if you're fast, because once you get the knack of it, you just look at this and you can write this down. And then you have your vertex right away, your zeros and your vertex, everything falls into place. Whereas here, you really have to do it step by step. You can't just see it from the start. So I hope this wasn't too difficult. See you in the next one.